Hello everyone. This presentation is an extension to the Chip Skills program intro. In this, we will try to explain the Chip Skills program in detail. This program has got 4 verticals: standard cell layout design, analog layout design, memory layout design, and the physical verification. Let's take each of the modules in detail. Standard cell layout design. In this, you would be trying to learn about standard cell library creation, what is the significance of creating a standard cell library, how to share the sources and drains, how to decide on the height of the standard cells, and much more. Using these standard cells, you would be creating combinational logic designs, trying to make much more compact logic in small area as possible. Likewise, you have sequential designs like this one, wherein you have a D latch, you have a clock signal and a data path. So obviously when you're using a lot of combinational and sequential logic designs, there is an influence of clock signals on the data path lines. So what care needs to be taken while dealing in such situations will also be explained. Moving ahead on the course, you will also be learning on much more complex designs like a hierarchical design, wherein you have to make a combinational design by flipping the power supply rails and trying to take care of the routing. If you see another example over here, it's a picture of a data path signal. Here you can see that there is a lot of routing, a lot of combinational logic. So you can imagine the amount of routing, the amount of effort, and the amount of complexity involved in this. You would be learning about how to do this and try to do the physical verification of all of such complex digital modules. It's not just doing the design, but also you would be taking care of the power strapping issues, how to do the power strapping in this whole design. By the end of this whole course, you would be learning about all the physical verification concepts as well, and you can very well apply for the role of a standard cell layout design engineer. Moving on to the next module, the analog layout design. We know that analog layout designs are a bunch of current mirrors and differential pairs. These are very different from the standard cell layout design, wherein here accuracy is something much more important. So there are different kinds of matching techniques we deal with when we are doing current mirrors and differential pairs. Why are we placing the devices in a particular fashion? What is the reason behind placing the devices like this? All of these things you would be learning in matching techniques like the interdigitation and the common centroid. On the picture here, you would see that there is an analog design wherein you have a current mirror, a differential pair, and a biasing circuit. If you see here, there are a bunch of resistors placed and capacitors placed. So there is a lot of difference between the standard cell layout design and the analog layout design. So obviously you would see a lot of varieties of physical verification checks over here. Moving ahead, as we make the course more complex, you would also be learning about high current designs, wherein you can see that there is a large switch over here of certain milliamps and a combination of digital and analog designs. So if you have to do a project, you can observe that there is a SAR ADC over here. Why these capacitors are placed at the top and the bottom, there's a digital logic on the right side, and all of these intricacies and the physical verification issues, and the very famous LDO and the BGR. So depending on whatever project you pick up, you can very well learn different concepts and aspects of analog layout design. So obviously you will also learn different aspects of physical verification as well. So at the end of the course, you can confidently call yourself as an analog layout engineer. Moving on to the next module, the memory layout design. Now this is something close to your custom digital design. So here we include the expertise of standard cell layout design and a structured kind of layout design style. So if you observe here, there is a memory array over here, there is a row decoder and a column decoder. All of these are custom digital designs. So how do we lay them out? Now here's the picture for you. So if you observe here, there is a memory array. You can observe that there is a decoder over here, There is a structured design, and how do we do this with a symmetrical approach. All of that you would be learning in memory layout design. Along with that, there are different kinds of memory architectures, wherein if you see this picture over here, on the right and left, there is a memory array and the logic in between. This is called the butterfly architecture. So all in all, you would be learning about different kinds of memories, different kinds of architectures and layout styles. So if you would have observed, there are 3 different modules with 3 different kinds of layout styles. Along with that, the physical verification aspects as well. So end of this course, you would be able to call yourself as a memory layout engineer. Moving on to the next module called the physical verification. You have learned about physical verification in the other courses as well. But then, physical verification is not just about fixing the DRCs and LVS. There is a lot more to it in the background. You may have fixed all of these errors like the spacing or the enclosure and all of that. But what is happening in the background? What it takes to do the correct setting, right? All of that you would be learning in this course. Likewise, we know that when fixing LVS, you've got schematic and the comparison between the layout, whereas in the background, there is a lot more to learn. So all those intricacies you'll be learning in the physical verification course. Apart from this, we also have internship programs for students wherein if they want to get the feel of a VLSI domain, try to pick up a small project or something of that sort to get the understanding of what is VLSI domain, understand the work culture, all of that. Apart from this, we'll also be offering mock interviews, resume building, LinkedIn profile, and obviously the placement assistance. Finally, you have a bunch of companies, in fact the ocean of companies to apply for. So you've got anybody in the product domain, the service and the ADS space. So finally, if you have any questions, any doubts, do write into us, connect with us on any of these social platforms, and do not forget to explore Semionic's website. Any questions, feel free to write into us and connect with us. And that's Semionics for you, creating a path for semiconductor industry. Thank you.